Welcome to this second in a series of tutorials for IBM SPSS Modeler, Data Manipulation. These demos will give you a good understanding of Modeler's powerful capabilities, which include accessing data, manipulating data, analyzing data, and deploying the results of your analysis. In the first demo, we introduced how to connect to multiple data sources. In this demo, we will show you how you can manipulate data within a stream and ready it for analysis. As a part of the analysis process, nearly all data sets have to be manipulated in some way to get the data ready for analysis. Data must be cleaned and processed for presentation to an algorithm, such as logistic regression or random trees. IBM SPSS Modeler makes it easy to modify rows and columns of information in the dataset in order to prepare for eventual analysis. To start, let's first identify what fields will be part of our analysis. IBM SPSS Modeler identifies the metadata associated with an analysis through a type node. The type node's primary role is to identify the data types of columns and what roles they will play in further analysis. When added to the stream, all other downstream nodes can make use of this information, so it's not necessary to keep adding this information about the data each time. When the Read Values button is clicked, it automatically samples the dataset and selects the best measurement type and values. Of course, you can always clear these and choose your own. The last column, Role, is used by downstream modeling nodes to tell whether a column will be used as an input, be used as the target, or be completely excluded from use by the algorithm. During an analysis, it's helpful to view descriptive statistics and visualize the distribution of each column. IBM SPSS Modeler covers this with the Data Audit node located on the Output tab. The Data Audit node computes basic and advanced statistics and conducts a quality analysis and lays the results out in a friendly table format. Metrics such as min, max, sum, range, mean, and others are shown on the screen along with a histogram of each column's data. When we click the histogram, Modeler will take into account the target defined in the type node and overlay it on the histogram. Based on this analysis, we see certain customers are showing an age less than 18, which means we need to remove them from the analysis. We'll do this in the next step. Before we leave the Data Audit node, clicking on the Quality tab gives us another friendly table format where metrics such as outliers, extremes, and the number of records missing data are collected. To include or discard records in a dataset, we use the Select node under the Record Ops tab. The Select node creates conditions in which records are included or excluded from the dataset. If you know SQL, this is where Modeler is building the equivalent of a where clause. To build the condition, we can type the formula directly or click the calculator icon and use the Expression Builder. The Expression Builder works the same way as the Microsoft Excel formula bar, and in most cases will share or use similar function names as Excel. When we need guidance, we can browse and paste functions from the left side and dataset fields from the right. Finally, another benefit of running the type node previously in the stream is that the Select from Existing Values function is active. Here, actual dataset values can be viewed and pasted directly into the condition. When the Data Audit node is run again after the Select node, the minimum value of the age field is now 18. All records with data less than 18 have been removed. In preparing an analysis, it's often necessary to change or regroup data. This functionality is found in the Reclassify node. Reclassify gives the option to take one or multiple fields, retrieve the results, and map to new values. It can then add the new values to either a new or existing column or columns. The last node we're going to discuss is the Derive node. The Derive node creates fields from any values. Nearly every time we use a Derive node, we'll do so through the creation of a formula, leveraging the same Expression Builder as the Select node. In this analysis, we need to create a new column called Marketing Target for customers who are 55 or older and are a car owner. The Expression Builder works exactly as before, with functions on the left side and dataset columns on the right, making quick work of our new formula. Once complete and previewed, a new column, Marketing Target, is part of our results and the correct value is assigned to the record. Finally, throughout this video, you may have noticed the nodes changed to the color purple when the stream was executed. This is because SQL Pushback, a valuable and potentially time-saving feature found in certain editions of IBM SPSS Modeler, is turned on. When present, SPSS Modeler turns node instructions into a set of SQL statements and sends them to the database. This shortcuts the need to move the entire data set to Modeler, and instead only moves the data needed. You can test for SQL Pushback by selecting a node and clicking the purple hexagon in the top palette. Those nodes that turn purple are part of the SQL query. By viewing the messages under the stream options, we can actually see the SQL that's being generated. In this case, the green highlighted area is showing the join between the two tables. The pink includes the select node condition we created and placed in the where clause, and the yellow highlighted regions show where we reclassified our data and created a new field. In this video, we learned how to successfully manipulate data inside IBM SPSS Modeler. In the next video, we will learn how to complete our analysis.